go to our chat and you can ask any question. So I say hi first. Right, hi. Okay, for this session, I introduce myself. My name is Shafi Farhan. Okay, for today's session, we will directly go to Inventor FEA Analysis, or we call FEA is finite element analysis. Okay, for Inventor FEA Analysis, later on we will cover on how the workflow work on, and also uh, how we operate the software to do the simulation. Okay, so after this, when you have any issue, you can go to Acad system website by clicking on our website acadsystem.com. And if you have any question to ask, you just can go to this area, click on here, put your name, email, phone number, and message. So our team members will help you to solve your issue. Even though you want to know about the pricing of software, about technical issue, you can ask over here. And we also have our help desk, which you can click on this main page using this menu bar. Click on this help desk. All right. So because this topic is quite complicated, so I directly go to FEA analysis. Okay, welcome to everyone. Okay, for those that join us from Facebook, you can, if you have any question, you just comment. Later, I will reply from our Facebook page. And for those that join our live, our Zoom meeting live, you can also ask any question. All right. So what the good things by doing simulation? Okay, the more powerful your design stage, the more complete your design stage, the more better decision sooner in future. For example, I have one item that I don't make any simulation on this item, how to predict what will happen when the product become already been production doing the production things. Okay, so what, when, and how. Okay, this will be the area that you need to know, or you need to learn about simulation. If you worry about will my part fail, or what will it fail, you want to know when it will fail. Okay, so this will be all the question that always design department or engineering department wants to know about their own product, their product that already manufactured. Okay, will it overheat and so on. So using simulation, you can solve this issue and try to do optimization in terms of design stage. Okay, you can do some editing on your 3D model and try to redo again the simulation before you go to the mass production. Okay, this will be the solution that Autodesk give. They will have a few types of simulation software. The first simulation, which is we call it as Autodesk Nastran Acad, or we call it also Autodesk Nastran, which you need to install the plugin inside Autodesk Inventor over here. Okay, for structural mechanic, you can use either you use Nastran or Fusion 360, both also can. Right. So for structural architecture, you can use robot structure analysis. Okay, this will easily to simulate what the how many loads that this structure can stand for. Okay, for flow and thermal analysis, you can directly go with Autodesk CFD, computational fluid dynamic, mold flow process, mold flow advisor, or mold flow insight, these two. Right, so this another software that you want to do topology optimization, you can directly go with NetFab. And for those that love to work with cloud, so better you choose Fusion, CFD, Moldflow, or NetFab. So this for solution that Autodesk give to client to use. All right, so the strategy. Okay, industry that need simulation, which is automotive. Okay, for automotive, they have a few parts that automotive and aerospace. The simulation that take part is almost the same. because for this for the metal part you can do the finite element analysis analysis simulation, and for the airflow maybe you want to know about the shape, the power, the hydrodynamic shape that you want to create after the design stage done. You can use CFD. So for consumer product, you can use the mold flow. You can study the heat inside. Also goes for industrial equipment and architecture and construction. Right. So before I start in detail, I want to introduce about Autodesk Product Design Manufacturing Collection. So inside this bundle or inside this collection, you will get more than 20 software, which is very good for you. Okay, for this will be the workflow that normally all company will face: the sales and bid, design and engineering, production and services. Okay, for sales and bid, you can use 3ds Max to make your product visualize and to make your product look real. For design stage, you can use Fusion 360 or Inventor. Then you need to use Nastran to do simulation to get the data that can improve your design in future. Okay, for production design and production stage, you can use Inventor Cam to do 2.5 axis 2 until 5 axis cam CNC simulation CNC, right, and other software. So all this software is included in product design manufacturing collection, and AutoCAD also include inside this bundle, right? So AutoCAD itself already have 8 software: AutoCAD mechanical, electrical, and so on. So you can try to fully utilize your bundle. If you already purchased the bundle, you can install the Inventor Professional, then also install Inventor Nastran to do simulation. Maybe you want to test first. You can use Inventor Nastran inside your Professional. Later, if you want to do GDNT, geometric tolerance and dimensional, so you can use Inventor tolerance analysis inside your Inventor Professional also. Okay, this will be the workflow that related to your product workflow. So now I want to share about what is FEA Analysis Workflow. If you already purchased the bundle or you already have the standalone Inventor, single product Inventor. Okay, they will have 3 type. Okay, 3 source. Okay, either your model, your 3D model or 2D drafting drawing from AutoCAD, or you already create your design using 3ds Max, or you receive your drawing from SolidWorks or from other software. You can convert it into Fusion or Inventor, because these 2 software they have one new features. If you use Inventor 2021, you can import any CAD. Okay, for example, I have one client that use other software, then want to do simulation using Nastran. I just simply import using Inventor. Okay, then for finite element analysis workflow, okay, you can use either you want to use Nastran or you want to use Inventor simulation, which is Inventor stress analysis by default already inside the software, Inventor software. Okay, or if you want to use Fusion 360 directly, use Fusion 360 Nastran there. Also have the simulation there. You just simply click Fusion 360 simulation. Okay, so they will have 2 methods. You want to use either simulation, stress analysis, or Nastran. Both can. Okay, later if you want to know details what the difference between these 2, you may ask. Right, so this will be the most important area that we need to cover, and for this time I want to do this object, this yellow object and the pin, included pin. Okay, so in initial, I already have the information of the parts. Okay, these parts using material, steel, density already have, young modulus, ratio, loads, and so on. Okay, also about the pins information. right? So using Inventor FEA Analysis, even though you use stress analysis or even you use Inventor Nastran, this will be the step that you need to go first. Idealization, boundary condition, run simulation analysis, and redesign. Okay, so I go to my software first. All right, so this will be the .iam file that I already create. Same like the information that I already have. Okay, for every single part, I can directly put the material, or material can be done after you do this. After you click the simulation button. Okay, to open the simulation, click on Environment tab. Okay, they will have either you can click Inventor Nastran or Stress Analysis, either one. Okay, for this topic, for this session, I want to share about how we use Inventor Nastran to create, to do simulation. So I just can simply click on Inventor Nastran. Then this software will help you to generate, to change to add another tab over here, Autodesk Inventor Nastran tab. Okay, what can I say when you see the Nastran tab? Okay, you can do one by sequence. Okay, for example, material, idealize, connector, surface, structural, or you can jump this tree, directly go to constraint, load, and so on. Okay, so to start my presentation, so I go back to this information. I need to put the information, the data given over here, design information over here. Okay, the material should be steel, density, Young modulus, and so on. So I go to my Inventor. Okay, the first step, I need to click on material. Okay, so you can directly select material and directly select Autodesk material or Inventor material, or you already have your own material, you can use your favorite material. Okay, for example, I choose steel. Okay, all the information over here will be automatically generated. Okay, then you hit OK and change it over here. Okay, just follow. Okay, by default, I already set the material. Okay, this material over here, I already set these two materials. The first one is mild steel, okay, 20, 0.29, and the second one is steel alloy over here. Right? Okay, after you're done with material, what you need to do is click idealization. Okay, for example, here, when I click the idealization, so the first step, I need to choose what material that I want to use, because I already create mild steel and alloy. Okay, for example, I add another material over here. I select material, choose, and I choose aluminum. Okay, and hit OK. Right? So I need to click idealization. So choose aluminum over here, and directly click on here, associate geometry, and choose what 3D parts you want to include in your idealization. Okay, by default, also I already set this solid 1 and solid 2. Okay, solid 1 is for this part. Okay, I double check. Okay, so solid 1 and solid 2. Okay, so I need to change here. Right, so right click here, edit. Right, so here pin 1 and pin 2. Okay, for this solid 1, I edit. So here will be this yellow color object. All right, so that will be the first step, which is we call it as idealization. Okay, the step should be like this. You just tick on the material, choose material, and after you already enter the name of material, the material will go to your idealization. Tick associate geometry and click on the object on 3D parts. Okay, that's the sequence for idealization and material. Okay, for second part, we need to put the boundary or the constraint. Okay, to do constraint, the button you can go to here. Either you can click on constraint, okay, or you can click on the pin constraint or frictionless constraint. Okay, when you click constraint, okay, so by default, when you click constraint, all the degree of freedom will be ticked. Means this part will don't have any translation and also rotation for constraint. But you also can change it. When you click fix, all will be ticked. When you click no rotation, only translation. Okay, sorry, no rotation, no translation over here. No translation, no rotation, and for example, free. So all degree of freedom will be unticked. When you plan to put fix, you can click on fix, all will be ticked over here. So I try to put here first. Okay, or maybe I already missed one step. Yeah, I try to simplify. Okay, I try to cut half. All right. Okay. So over here, I need to click on constraint, select all, fix, tick all means to tick all. So choose entity, this face and also this face. So I want these two face, these two area will fix. Okay, to edit your constraint or anything, you can go to this model tree, this Nastran tree. So just right click, edit. Okay, for example, you want to see more arrow, you can increase the density and change the color. Okay, now you can see the arrow over here. All right, so the second setup, you can double check back. So the second setup, we need to put the frictionless into this face. Okay, we assume that this object, we want this object to have movement on the Z direction. So you can click later on the Z direction. Okay, so just click on here. Either you want to directly click constraint first and no rotation, or you frictionless also can. So directly click on this face. So don't forget to increase density and change color. Okay. Okay, when you click on the face, the constraint will be take action on all entire face. All right, so the next step is about load. Okay, for this load, we try to use bearing load a bit different compared to normal load that you are using. Okay, for example, over here, okay, to click load, to add load, so over here on the setup, they will have load button, click. Okay, don't forget to rename. For example, this one, I want to put it as a pin load. Okay, ID1 or ID anything. All right, so type or force, type for your load, you can put as a force, moment, or gravity, and so on over here. Okay, but if you use, this one is different, quite different when you use Inventor stress analysis, because Inventor stress analysis have very limited type of load. Okay, when you use Inventor Nastran, you have including temperature, radiation, and so on. Okay, I click over here, click on the bearing load. Okay, the first one I want to put here. For example, I want to put over here, norm, this one. So I tick. Okay, to show it directly, you can click on this preview button. Okay, so the load for X, I just put -15. Okay, so over here. Okay, but the issue is I don't want this file, this object doing like this. I want the force, the load become go with the same direction. So I just need to change from normal to surface, change to component over here, right? And hit OK. Get it. Okay. All right. Material, idealize, friction, the constraint and load are already done. Okay. Now we want to control the mesh. Okay. For example, all face I want to make it the mesh size one unit. Okay. But for this area, I want to change the mesh size become 0.25. So what things that I can do? I can click on the mesh control. Okay, the element vertex I change into 1. Part data I change into 1. Okay, the surface I change into 0.25. Okay, for this face I need to click over here. Okay, don't forget also density and colors. Okay, then after done, you just hit OK. Okay, so later in this part, the meshing will be a bit, the triangle will become a bit smaller. Means you want to know more details on this area, or this area is not possible if you create 1 mm. So you can change specific area to another control of mesh. Okay, and next you can click on this auto contact to make sure all the parts contact each other. And don't forget to click all this contact, edit, change from bounded to separation. So means the software will know that all part will be separate each other. Become every single part. When you click on the bound, the software will assume all this become one part. Okay, click on the separation. Okay. Okay, click on the mesh setting, put the value 1 something and generate mesh. Okay, so after done, you will see that this area will be have little bit smaller triangle compared to this area. So I try to hide. Okay, okay, if you can see, the area have smaller triangle compared to other parts, because other part we already set it into 1 mm. So but this part we only set it into 0.25 mm. Okay. Okay, so after you done with all this sequence, what things that you need to do, you just click on run and make sure your part can be simulated. If they have any pop-up error, try to study the error or by clicking the error. For example, here I try to click on this part. Okay, right. So for this case, I try to make it this part Inventor Autodesk Inventor Nastran solution fail. Okay, when you go to your tree over here, they will have fatal error E5000. So you can copy and just Google fatal error Autodesk Nastran, and at their Autodesk knowledge forum, they will have a solution. Might be your file is not automatic contact. So after I do the automatic contact and I click on run, so it should be become much more better and the result will be there. So just need to know what error that you are facing. Okay. So I show you once about our sample. Okay, for this type of simulation, it will take you around 30 seconds to 1 minute to generate the result. Okay, so while waiting to this result, okay, what can I say over here? This will be the simplified method to get to know about your product strength, or to get to know about where is the part that will be defect first when load applied. Okay, so for this case, by default, why I put over here, because I want to study more about this edge. if I want to, for example, if I already know this this fillet is not good enough, then I can change it, the size of fillet, to make it my part stronger. Okay, so while waiting, all right. So after this, I will tell about is that you need to do your simulation by part or by assembly. Okay, which one is better? Right, I click on deform to make it the object look real. Okay, so by default, I see that the solid von masses, this will be the part that gain 10 megapascal value, this area. And for example, I want to study about the displacement. I can click over here, click on stress, click on displacement. Okay, for total, this will be the area that reflect much. Okay, when you convert back into your actual data, this will be 0.0000324 mm. Okay, because this unit is in mm. So means the defect is not too much for this type of parts. 0.0003 mm. Okay, so this will be the displacement, stress, von masses. You can change all the information. Okay, if you plan to generate a report, you can click on here to generate a report later on, or can create a report over here. All right, so now I want to share about which one is important. Okay, so I repeat back the step. So this will be the step. Click on the face, 0.25, 1 mm. Okay, this one that I know that the most von masses value will be here. Then I want to learn more about this face. Okay, put the contact, surface contact, and change into aspiration. Okay, and result. All right, so after this, if you have a part or assembly, better you try both. Okay, by default, when this part, I also try to try to create using part analysis and also assembly analysis. So the result for part, the result will become 0.0029. But when I use into assembly analysis, the simulation result will become 0.00324 something. Okay, so this will be the area that you need to know. And my suggestion, better you go with both. Try to practice, try to do some sort of study for part analysis and also for assembly analysis, so that will give you a clearer idea. And the most recommended things by Autodesk expert on knowledge Autodesk, they will suggest you to go with good practice from part analysis and good idea. So you can go between both. Okay, extra movement in assembly will result in the higher stress than part analysis. Okay, so this will be the information that good for you. Okay, normally if you plan previously, you plan to create your simulation one by one by parts, also can. If you plan to do by assembly, also can. But I don't suggest you to do simulation in the real product. For example, you have a full product that have more than 30 parts. So then no need to do simulation on that specific parts, because you will take a long time to generate the mesh. Okay, so that's the idea and the flow using Inventor Nastran. Okay, so what the difference between stress analysis and also Inventor Nastran? Okay, by default, this will be the type of analysis that can be done using Inventor. But if your part only require FEA analysis, you can use linear static analysis. Okay, for example, sorry, if you only need linear static analysis, you can use either you want to use only stress analysis or Nastran, should be fine. Okay, but for material or properties consideration, only linear material. Okay, for example, you want to learn about plastic. For any additional features here, you need to use Inventor Nastran in CAD. Okay, so that will be very good. Very good information for you. You can screenshot your screen to see the difference between Inventor stress analysis and also Nastran. All right, so I will run some poll. Either you know you learn here. All right. Okay, I believe all of you will receive the poll and you can answer it. But and if you have any question, you can see on screen. Okay, they will have my numbers and also my email. To if you want to ask more, you can directly contact through email, or you can go to our acadsystems.com website, go to help desk and click create a case. You just simply paste any issue, and our technical team will try to solve and try to engage with you to solve your issue. Right. So I think for today, I believe all of you done with the pool. Okay, I will end the pool session. Thank you. All right. All right. So thanks for your voting. Okay, question and answer. Right. So if you have any question while waiting for this, if you have any question, you can go chat over here. Okay, I show you this slide again. Okay, if no, I will end this session. Thank you so much for your time. Don't forget to follow our next topics of webinar. And after this, we also will do some sort of Inventor advanced training online session, online lesson classes. Okay, sure, welding. Right, so later on we can do. Okay, thank you so much for your time. All right, I will end the session. Okay, bye-bye.